In this video, we're gonna design the ring counter that we have discussed in the previous video. So first of all, what we're gonna do, we're gonna create a new Verilog file, and let's save it as ring counter. So we need to create a module. So module name, it is ring counter. And then we have our inputs. So if you remember on our discussion on the previous video, we have the input is only clock and start, and the output is the Q, the output of the flip-flops. So we have clock, start, and Q. End module. So we need to declare so this is going to be a parameterized ring counter. So parameter, and then we can say for, and then input, we have clock and start. So all of them are 1 bit, and then we have output Q, so output, and then this is going to be reg output, and then this is, since it's parameterized, so it is n-1 0. So now what we need to do, it is to assign those flip-flops here. So we need an always, and so this always, it is event driven block, so it will run at positive edge. So the first what we can do now, initialize our counter. So if start, so we can say Q, it is equal to, for example, 1, and then else if, and now here we need to assign all the output of the flip-flops. So what we need to do, we need to create a for loop. So first of all, we need a integer, and then we can say for e is equal to 0, e is less than n-1, or e is equal to e plus 1. Begin, end. So inside this for loop, we need to create all the, because this is parameterized. For example, the first Q, which is depend on the E, is equal to the next Q. So it's just equal to E plus 1 and then now what we have done now is create we have connect from Q0 to Q3. So this strip here, and then we need the last connection here, and this is only happened one time, so we can do outside of the loop here. We can say, we can write Q, the last flip-flop is equal to the first flip-flop. So that is the code for the ring counter. Let us save it and set it as our top level entity and try to analyze and synthesize to see if you have done everything correctly. We have some errors here. Let's check the errors. We have error line 6 and 14. 6, we didn't declare the Q. Let's declare the Q. And 14 is else if. Okay, it should be only else. So first we initialize, and then we try to do this task here. So the if shouldn't be there. So let's save it and try to analyze and synthesize again. Yeah, so we have done everything correctly now. So in the next video, let us design the test bench file for this.